Hey everyone, here's Ellipse Day 2 notes and examples. And here again we have the notes page. If you already have them, then great, you can just follow along. If not, maybe print them out so you can have something to write on. Okay, so we have writing equations of ellipses. So we need four things in order to write the equation of an ellipse: the center, the value of A, the value of B, and whether the ellipse is vertical or horizontal. So let's make a quick sketch of the ellipse described, then use the sketch to help write the equation of an ellipse with the following properties. So we have vertices at -10, -2, and 0, -2. We also have co-vertices at -5, 0, and -5, -4. So if we want to draw this graph, not very good graph here, but here's the point -10, -2, and we also have the point -10, -2, and we also have the point 0, -2. Those are vertices. We have co-vertices at -5, 0, 1, 2, 3, 4, -5, 0, and -5, -4. So there are all of the edges of our ellipse. So then if we wanted to do a little sketch there. Okay. You wouldn't really need to draw this graph if you know the properties, but for the vertices and co-vertices, if I choose either one of these, say the group, the vertices or the co-vertices, I can find the midpoint of either one. So if I'm just looking at the vertices here, so if I've got -10, -2, and 0, -2, halfway between that would be, so -10 plus 0 divided by 2, using that midpoint formula, that's -5, -2. Could have done the same thing with the co-vertices. So the x value would have stayed the same since it was vertical, but the y value, 0 plus -4 divided by 2 is -2. That's where the center is from. The a value will be the distance it takes to get from the center to the vertex, or one of the vertices. So the vertices are at -10, -2, or 0, -2. So either direction, that would be a distance of 5. B is the distance from the center to a co-vertex. So here from 0, 0 to say, not 0, 0, -5, -2 to -5, 0, that would be a distance of 2. And then this is horizontal. So I have the four things needed for the equation. So let's see, we'll have x something squared over, let me just write up the skeleton of it here. It's always equal to 1. Okay, so the center is at -5, -2, so the opposite sign. So I'll have x plus 5 and y plus 2. And then because it's horizontal, the a squared term will go first. So 5 squared is 25, and b squared is 4. And there's our equation for number 1. Let's look at another. If only A or B is known, sometimes C must be used to calculate the other crucial missing variable. So we can use the formula C squared equals A squared minus B squared to achieve this. So here's number 2. Let's make a quick sketch of the ellipse described and use a sketch to help write the equation of ellipse with the following properties. So we've got 4, 8, and 4, -4. So let's see here. So we've got 4, 8 up there, 4, -4, so somewhere over here. Foci are at 4, 4, and 4, 0. So that's a foci, this is a foci, or focus. This would be a co-vertex and a co-vertex. Just kidding. How about vertex, because it even tells us that. So there's a vertex right here, a vertex right here. So I should know that right in the middle of all of that is going to be the center. So seeing how the vertices, foci, and the center are all lined up vertically, I know that this whole ellipse will be vertical. So the center, if I use the midpoint formula on either the foci or the vertices, I'll get an x value of 4, and 8 plus -4 divided by 2, or 4 plus 0 divided by 2, get 4, 2. A is the distance from the center to a vertex. So to get from the center at 4, 2 to a vertex at 4, 8, we go 4 units. How about 6? 4, 2 to 4, 8. From 2 to 8 is 6 units. Alright, C would be the distance from the center to one of the foci. So from 4, 2 to 4, 4, or 4, 0, that would be 2 units. But we need B for the equation of the ellipse. So if we use that formula, c squared equals a squared minus b squared, c squared is 4, a squared would be 36. So then we would get if I, if I subtracted the 36 over, so negative 32 equals negative b squared. So 32 is b squared. So then b would be the square root of 32. And if we wanted to make that simplified, 32 is the same thing as 16 times 2, and the square root of 16 is 4. So that would be 4 times the square root of 2. Either way, so we'd have b is the square root of 32, or 4 square roots of 2. And the reason, and I'm not really going to emphasize, you don't really need to do it this other way here. I'm not going to emphasize that because in the equation we would need b squared, so the square root of 32 squared would end up, the square root just goes away. So if we have the center at 4, 2, so we have x minus 4 squared. Over here we'd have y minus 2 squared. It's always equal to 1. We know that this is vertical. That means the b squared term will go first. So the square root of 32 squared is 32. And then a squared is 36. And there's the equation of this ellipse. Okay, now looking at number 3, we're going to write the equation of an ellipse with the following properties. So we've got a coordinate of the center is at 3, negative 5. Okay, well that was given to me, so I'm just going to go ahead and put my center is at 3, negative 5. We know the length of the major axis is 20. Don't forget the major axis is 2 times a. So if 2 times a is 20, then a is 10. The length of the minor is 8. The minor axis is always 2 times b. So if 2b is 8, then b is 4. The major axis is parallel to the x-axis. So that means the x-axis, it's going left and right, and the major axis, the longer part of it, is also parallel to the x-axis. Then that means this is going horizontal. So then for the equation, x minus the x value of our center, so x minus 3 squared. We've got y minus the y value of the center, so y minus the negative 5 is y plus 5 squared, always equal to 1. It's horizontal, therefore a squared will go first. So 10 squared we get 100, and 4 squared we get 16. And there's the equation of this ellipse. Number 4. So here's this information we are given. The ellipse is a vertical. Alright, right away I'm just going to go ahead and circle vertical because it's given to me. C is the square root of 10. Okay, the coordinate of the center is at 2, 4. The center is at 2, 4. The major axis is 12. And I know that the major axis is 2 times a. So if that equals 12, then a is 6. So we need to find b. Well, we know a. We know c. So we can use that formula that c squared equals a squared minus b squared. So c squared, the square root of 10 squared, is 10. So I have 10 equals a squared will be 36. So I'll end up with b squared equals 26. So then b would be the square root of 26. So b is the square root of 26. So I have all of the information needed. So I'll have x minus 2 squared. I'll have my y minus 4 squared, always equal to 1. It's vertical, so the b squared term will be first. So the square root of 26 squared is just 26, and then a squared is 36. And that's our equation. These really aren't bad once you've done a few, right? Okay, number 5. We have foci are at -12, 3 and -2, 3. We can figure out 2 things with that one piece of information, or I guess 2 since we have 2 foci. We can figure out the center by using the midpoint formula. So the center is going to be halfway between these two. So -12 plus -2, -14, divided by 2 is -7. So the x value of the center is at -7, and it will have the same y value of 3. And you can add the 3 plus 3 divided by 2, you'll still get the 3. But the second piece of information that we can get from this is the distance from the center to one of the foci will be equal to c. So -7 is how far away from -12 or -2, and that's 5 units away. We're also told the length of the minor axis is 10, and I know that the minor axis is 2 times b. Therefore, b must be 5. But we need a. So again, our little friend here, c squared equals a squared minus b squared, will be 25 equals, we don't know a, b squared is 25. If I add that 25 over, I'll have 50 equals a squared, so a is the square root of 50. A is the square root of 50. And then vertical or horizontal, if you need to draw a picture, you can. But I have foci are at -12, 3, -2, 3, and the center is at -7, 3. Notice they all have the same y value. That means they'd all be left and right of each other. And foci are on the major axis. So that means the major axis will be running left to right, and therefore it's horizontal. So the equation will be x plus 7 squared plus, and this part will be the y minus 3 squared, and then over here, equal to 1. It's horizontal, so the a squared term is first. Square root of 50 squared is 50, and the b squared is 25, and that's our equation. Okay, so now let's switch our thoughts here for just a moment, and these next few problems are actually really quick. So even though they look totally different than what we've been looking at, they're pretty quick problems. We want to rewrite these equations in graphing form. So in other words, we want to put them back into these standard form where we can see the a squared and the b squared and all of that quite easily. So on number 1 here, I've got 25x squared plus 4y squared equals 100. Couple of things you notice. There's a 25 and a 4 in a weird place right there. We don't have any terms, any coefficients in front of the x or the y's. And also, the equation should always be equal to 1 for an ellipse. So the easiest way to look for this is, don't worry about that 25 and 4 for a second. I know this 100 should be a 1. So if I divide every single thing by 100 and simplify it, then I'm going to get my equation. So 100 divided by 100 is 1. 25 over 100 is the same thing as 1 over 4. So I have x squared over 4. 4 over 100 is the same thing as 1, so 1y squared over 25. See? Not bad. Number 2, same thing here. I've got a 144. I don't like that right there. Let's divide everything by 144. So we need to reduce these fractions. So that instead of having 4 times x minus 3 squared, 4 over 144 reduces to 1 over 36. If you don't believe me, you can check it out in your calculator. Instead of 9 times y minus 1 squared, 9 over 144 reduces to 1 over 16. And then, of course, 144 divided by itself is just 1. And then we have one more of these, number 3. And this time it is equal to 72. Easy fix, right? If I divide everything by 72, So I'll have x plus 2 squared. 24 over 72 reduces to 1 over 3. 3 over 72 reduces to 1 over 24. And 72 divided by 72 is just 1. Then let's look at this last kind of problem. We've got 3 of these here. And for the general form of a conic, we've got ax squared plus cy squared plus dx plus ey plus f equals 0. And we looked at this in class, and we were able to change this into the standard form of a circle, but now we can do the same thing with an ellipse. So what we're going to do is, looking across here, I'm going to refer back to this crazy looking polynomial we've got up here. We know it's an ellipse if a does not equal c. The coefficient in front of the x squared and in front of the y squared are not the same, and a times c is greater than 0. So the coefficients when multiplied together are still positive. So here the a value is 1, the c value is 4. So checking that a times c, 1 times 4, well, that's 4, and that's greater than 0. So that one checks out. This is an ellipse, and a and c are not equal, right? 1 does not equal 4. So we know that we're dealing with an ellipse here. Okay, so let's do what we did before with the circles. Let's group the x terms together and the y terms together. And at the same time, I'm going to go ahead and add in the boxes. So I've got plus 4y squared minus 8y. I'll need to add a box there, equals, and add the constant over to the other side. And here I'm going to have to add 2 separate things. I ran out of room, so I'm going to put it right there. Okay. Well, in this first part, I can go ahead and factor that, or complete the square. So I have x squared minus 4x. Negative 4 divided by 2 squared is 4. I'm going to add a 4 right there. But before I can do anything else here, let me take a moment and look at these y variables. I've got a value in front of the y squared that is something different than 1. So what I'm going to do is factor out that 4 so that I have y squared minus 2y. So that will be my new box there. So I already figured out this first box. And then I'll have 28. I'm adding that 4, but I also need to add something else. Well, negative 2 divided by 2 is negative 1, and then squared is 1. So we're adding a 1 right there. But we're not just adding 1 to the other side. Don't forget about this 4. We're adding 1 times 4. So we're going to add another 4 to the right-hand side. Now this left-hand side factors into x minus 2 squared. Then we have plus 4 times y minus 1 squared. Just factor what's in the parentheses. That's y minus 1 times y minus 1 equals 28 plus 4 is 36. Now we have a problem just like 1, 2, and 3 from a moment ago, where I need this equal to 1. So if I divide every single thing by 36, then my equation will be x minus 2 squared over 36 plus 4 over 36 reduces to 1 over 9, and then 36 divided by 36 is 1. So that would be the final equation right there. Let's look at another one of these. So number 5, 9x squared plus 4y squared minus 54 minus 8y plus 49 equals 0. First of all, let's check to make sure that this is an ellipse. So we have an a value of 9, a c value of 4. Those two things are not equal, so far so good. And I also need to make sure that a times c is greater than 0. And so 9 times 4 is greater than 0, so we're good. So now we're going to do the same thing we did before. Let's put the x things together. So we have 9x squared minus 54x. We'll group the y terms together. So we have plus 4y squared minus 8y, and then move the constant over to the other side, so we have minus 49. Well, just like we had to do before, let's factor out the leading coefficient for the a and the c value. So we'll have 9 times x squared minus 6x, and that's when we'll add in our box. Plus, we need to factor out this 4 for the y squared, so we'll have y squared minus 2y, add in a box there, equals negative 49, and we're going to be adding two separate things here, one for each x and the y, completing the square. So negative 6 divided by 2 is negative 3, and then squared is 9, so 9 goes here. But I'm not just adding a 9 to the other side, I'm adding 9 times 9, which is 81. For the second box, negative 2 divided by 2 is negative 1, squared is 1, but I'm not just really adding 1, I'm really adding 1 times 4. So that would be plus 4 over here. So now I've got 9 times, if I factor this, that's x minus 3 squared plus 4 times, this factored is y minus 1 squared equals negative 49 plus 81 plus 4 is 36. And now's the easy part, divide everything so that it's equal to 1. So 9 over where'd my mouse go here? So we have 9 over, that's a 36. Okay, so 9 over 36 reduces to, so we have x minus 3 squared over 4 plus 4 over 36 reduces, so we'll have y minus 1 squared over 9, and then 36 divided by 36 is 1. I would like for you to do this last problem, this number 6 here, on your own paper and put it into standard or graphing form, and I'll see you in class. Let me know if you have any questions. I'm sure there might be a couple, and that's just fine. Have a great evening. Bye.